All right, everybody, so what we're going to do is we're going to practice writing the electron configurations for three elements: carbon, sulfur, germanium. We're just going to fill up our little chart here, so this is a great chance to get some quick practice. And so we're trying to follow some basic rules. Once again, atoms are trying to achieve stability through the lowest energy configuration, which means the most stable electron configuration. We're going to try to fill lowest energy levels first. We'll try to fill lowest or earliest sublevels first, and we're going to remember the idea that electrons want to spread out across orbitals in a sublevel, and they cannot have the exact same quantum state or the same spin for practical purposes of this particular lesson. So with those particular rules in mind, based on the lessons we just had and the practice we've had, give it a go. Try to write these. Go ahead and feel free to pause the video and work this out, make your little table, and then we'll see how you did. All right, folks, let's walk through one at a time. So we'll start with the carbon. I've written the electron configuration, and let's see where we got from. Carbon, if you're looking on your periodic table, is element 6, and being in on the second row, the second energy level in the P block, we know the configuration is going to end somewhere in there. First of all, we know that we are always trying to occupy the lowest energy level first for atomic stability. So we fill that up. 2 electrons. We've got 4 electrons left over out of that 6 to account for. We also, in the interest of stability, will occupy the one block at a time. So on the second row, we're going to fill that S block. If I stopped here, that's basically beryllium. So, but we still got 2 electrons to go. We're now in the P block. Notice that we are now moving to the boron. That's element 5. That would be the sp 2p1 square. If we stop at boron, we would say 2p1. But we're in carbon. We got one more square, one more electron, and we do account for the electrons occupying free orbitals whenever possible, so they are not going to pair up. We'll occupy an orbital that we would model as being like 90 degrees to the other orbital. And so, and just by tradition, we start off with that up spin, that up arrow. It's just a tradition, it's arbitrary. So that is carbon in a nutshell. So, and if you'll notice, our superscripts, 2 plus 2 plus 2 equals 6. Carbon is element 6. Okay, and we've been following our quantum rules to account for the things that make an atomic cloud more or less stable, and so that element keeps its electrostatic integrity. Ooh, well, whatever, you know. That's probably not the best way to say it, but here, well, let's keep on moving. Let's move on to sulfur. So sulfur is 1s2, 2s2, 2p6, 3s2, 3p4. Where does that come from? So let's go from carbon to sulfur. Let's just keep going. In fact, I'll just go ahead and model everything between carbon and sulfur, give you a little extra practice. So we would move here, that would be nitrogen, that would be 2p3. And then we keep moving right to oxygen, 2p4. And then we would move on to fluorine, 2p5. And then neon would be 2p6. We would stop there. If we were stopping at neon, we have obeyed all of our rules. But we're not stopping at neon. We're moving on to that third row. We're moving on to sodium. And then magnesium, and that would be magnesium. And notice that magnesium is the second square in the S block on the third row. In fact, just by looking at that, we know this element's identity. We don't even have to see all the other stuff. And then we are now in the block where sulfur is. Sulfur is the fourth element in fourth square in the P block. 1, 2, 3, then we double. Just keep following that rule, we're good to go. All right, now we're going to move on to germanium. Okay, germanium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p2. Or if we wanted to write this in noble gas configuration, we could basically sum all of that up right there. That's argon. And then just simply write out that. So that's, you know, could have been a little bit neater about that, but at any rate, you get the idea. So if I say you can write in the shorthand, there it is. That's how you would write shorthand. But let's go ahead and work it all out. So we're going to fill out that P block. So here's argon right there. And then we move on to potassium and calcium. We move across the D block. We fill the D block entirely all the way to zinc. If we stop there, it would be zinc. And then we finally finish off with germanium. There we go, 4p2. So, at any rate, here it is. There's our 3 exercises. I hope you did good. Once again, this is a week of so many itty-bitty picky little rules. But fortunately, I spend forever on this stuff. But that is just something to practice for electron configuration and error diagrams. And we'll do plenty more practice till everybody gets it down.